Right, good afternoon and welcome. My name's Damien. I'm deeply honored to stand here today as the chairman of the Hunza Racing Division, or as we like to call ourselves, HRD, for the 2022-2023 season. Thank you for joining us on this momentous occasion as we usher in a new era for our team, our universities, and global Formula student community. Since our inception, HRD has proudly brought together the brightest young minds to create extraordinary racing machines. We have put combustion engines to the test, overcoming engineering challenges and constantly delivering outstanding performances. We have turned potentials into top finishers and young engineers into leaders of their fields. However, as you all know, our journey so far has not merely been about winning. It's been about innovating, about learning, about pushing the boundaries of what is possible in automotive engineering. It's been about embracing the spirit of competition while also holding steadfast to our responsibilities towards our planet and future generations. Today we are here to reveal a testament to this commitment. Our first fully electric Formula student race car, the HRD05. We live in an era of monumental change. The world is swiftly transitioning towards sustainable energy. And in our corner of the universe, the racing world is no different. The roar of combustion engines is gradually making way for the hum of electric motors. And in face of such change, it is crucial not just to keep up, but to lead. That is why we at HRD have taken this electrifying leap. Our transition to electric is not merely about switching power sources. It's a statement of our values, of our beliefs in a sustainable future where performance and planet can coexist. It's about embracing the cutting edge of technology and adapting our innovative spirit to contributing towards this global shift. The race car we're about to unveil represents hundreds of hours of design, iteration, and testing. It represents the hard work of a diverse and dedicated team of students. It's not just a machine, it's the embodiment of ingenuity, grit, collaboration, and a shared dream. As we make this pivot towards electric, I want to take a moment to acknowledge every member of HRD, both past and present. Without their dedication, resilience, and passion, this would not have been possible. This change is a testament to their adaptability and unyielding commitment to our team's values and vision. Let's give the members of HRD a round of applause. I would also like to extend our deepest gratitude to our sponsors and supporters. Your faith in our abilities and your commitment to supporting student-led innovation is deeply appreciated. This transition has been possible due to your unwavering support. Let me assure you, this change does not mean we will lose our competitive edge. If anything, we're more fired up than ever. This is a new challenge, a new opportunity to learn, to grow, and to continue proving that student-led teams like ours can be at the forefront of technological advancements. As we stand at the cusp of this new era, we remember the words of legendary driver Mario Andretti, who once said, "If everything seems under control, you're not going fast enough." Ladies and gentlemen, rest assured, we at HRD have every intention to keep pushing, to keep innovating, to keep going faster. We are moving into a future that is as sustainable as it is exhilarating. As we reveal our first fully electric race car, we step into that future with unbridled enthusiasm and unyielding commitment. Thank you for being part of our journey thus far, and we look forward to your continued support as we race towards a brighter, faster, and more sustainable future. Thank you. Let's pull back the drape in a new chapter of our story. And now, to provide a little more information on the design of our HRD05, I'd like to invite our lead electrical engineer, Toby, and our lead mechanical engineer, Bas.
Hello, hello. Yes, there we go. Hello, thank you all for coming. I'm Toby, lead electrical at HRD right now, and
hello, I'm Bas. I'm the lead mechanical engineering at HRD. So, how did we actually build this car? We split up this car into 3 main systems: the rolling chassis, the tractive system, and the bodywork. The rolling chassis consists of the chassis, some driver protection, and suspension. This makes sure to protect the driver, contain all the components of the car, and make for a nice driving dynamic during the race. The chassis. We choose to design a steel tubing chassis. This is because it's relatively cheap, but it's very strong and protects our driver really well. And it's simple, but quite reliable. Here's a small video of when we just welded our chassis. So, to make the chassis actually drive, we added suspension. We choose for, once again, a simple and reliable suspension to give good stability in corners and a nice race car. So, we completely self-designed our suspension system, as can be seen here and on the car. We self-designed our uprights, our rockers, our A-arms, all that you can see here. And to finalize the rolling chassis, we have protection for the driver, which consists of the headrest. The headrest is a piece of foam behind the head of the driver to make sure that when there's a crash or frontal impact, the driver's head has some cushion. And on the front of the car, we add an impact attenuator. This makes sure that in case of a frontal impact, there's a crumple zone which reduces all the forces on the car and protects our driver. So, to make this rolling chassis drive, we have a tractive system.
yeah, so in an electric car, we need an electric tractive system. And the main functions of the tractive system are to store the power, which is done in the accumulator container, to manage that power safely with the high voltage box, and to transfer that power to the wheels, and that is done in the drivetrain. So first of all, the accumulator container. This part is also split in 3 parts. We split everything in 3 parts. So the first part I'll talk about is the battery segments. These segments, so our whole accumulator is built up out of 4 segments of 27 LiPo cells. So when you put them all in series, you get a total of 450 volts, and you get an output of 150 amps. This is more than enough to power our motor, and it can keep the car running for quite some time. It's also a great feature of these battery pouches that they're very durable, and they have great heat dissipation properties, which is quite crucial in a battery, as heat is the biggest, the biggest enemy for any battery. So that's why these cells are perfect for this. Then next we have our high voltage floor. So there's a floor in the accumulator container that separates all the high voltage components from the rest of the components. It insulates it electrically, but also has some fireproof properties. The main systems that you can see here are the activation logic PCB. This one takes care of turning on and off the car. Whenever there's a problem in the car, it immediately turns it off, but it checks with all the different PCBs whether it can turn on or off the car. Then you have the insulation monitoring device. This is crucial for any electric car as this checks whether the chassis is not connected to high voltage in any way. And if it was the case and you didn't know and you touched the chassis, it would not be fun. But the next one is voltage indicator. This is a small PCB that does a very small task, yet very, very important. A tiny LED on top of the accumulator shows whether the high voltage is connected or not. And it seems simple, but even then, the PCB had to go through so many different checks, and there's so many iterations. Then we have some safety plugs. They're the orange plugs on each segment. These plugs are very useful in our design. They're basically very easy to use, very easy to detach, and so we can more easily do maintenance. And we've arranged them in a way so that we can't connect them incorrectly, and no one can connect them incorrectly, so that we don't have big problems. So the next is the BMS, the battery management system. As the name can say already, it manages the battery. So ours is the Orion BMS 2. It checks voltage, it checks current, it checks the temperature of the battery, and it basically takes care of managing all the voltages of the battery. Ours is the Orion BMS, and it's the advantages of it are that it's very customizable, and it has really good heat dissipation, once again coming back, and that basically gives us a very, very heat-resistant accumulator container. We have no problems with cooling, thankfully. And it also has a lot of modularity so that we can add things, we can change things in the future if we want to reuse it. There's a lot of movement available. It's great. So that was the accumulator container. Next up is the high voltage box. So, like I said, this manages the power. There are a lot of PCBs in this one because for FSN there's a lot of rules. The first one is the Tractive System Active Light. Also, a very simple idea. It's just a light on top of the arch right there. It's on there. It is green when there's just low voltage and it's safe to touch, safe to go in, safe to work on. And it blinks red whenever there's high voltage active. But this system has to do many checks all over the car with different type of systems to check for sure is it safe, and then it can turn it on. Then we have motor brake combination safety PCB. It's called the BSPD. It's it's called brake system plausibility device. It's a little too much. So I just call it motor brake safety PCB. It basically keeps you from pushing the accelerator and the brake at the same time, because when that happens, you are pushing the motor while you're also pushing against the motor. So you can blow up your motor. Many bad things can happen. Then we have the latching circuit. If any problem occurs, it has to stay off. This is basically what the PCB does. It latches so that the car never turns off again, or it turns on again, even if there was a problem, and you have to reset it. So for all of these PCBs and this whole system, there's a shutdown circuit running through it. It's like a big chain running through all the PCBs. And in this case, it's running through all of these PCBs, running to the plug And this chain, if it's disconnected in any way from any of those PCBs, the car immediately turns off. So it's like a big check going through all the PCBs, and if one PCB notices a problem, car immediately shuts off. And here you have it to the plug, so we can just take out the plug if we see any problems and the car shuts off. There's many more different little systems in our car. If you want to learn more, join the electrical team. No, but yeah, you can always ask us questions. We'll be in the back if you have any interesting questions. But yeah, that's the high voltage box. So combined all that power has to be transferred to the wheels.
Yes, to actually put this electrical power into mechanical power, where we can drive our car with, we designed a drivetrain. For our drivetrain, we use a 30 kilowatt custom Combi-Mag motor. This is a very efficient motor which makes very good use of all the electrical power of our tractive system. We've set up a good gear ratio, so we have a fast acceleration. So these three main components make up the tractive system that will drive our car. Then, to top our car off, we have bodywork. We have completely self-designed and produced our bodywork. We have designed a nose cone and 2 side pods. We have made these with the use of custom molds, and we laminated them with carbon fiber and epoxy.
So all these systems together make our HRD05, and we're very happy that we finally have this presentation, and that is one part, one chapter, but we're missing one more part of this car, and that is what Mikhail will tell us about.
Hello, hello. All right. As we have heard already from the mechanical and the electrical department, the story of the car that has just been finished and revealed, we still need to talk about the future of HART, because there's big promises, and when we talk about the future of HART, there's one more department we have to talk about, and that is the driverless department. My name is Michael, and I'm the lead of the current driverless department, and I would like to walk you through what we've been doing and what we would like to do. So, first of all, why driverless? As Damien already said, the world of the automotive industry is changing rapidly. And not only that everything's being converted to electrical, the current promise, the current dream is to make all cars, all vehicles autonomous. That will save us a lot of labor and also make our roads safer, hopefully. And to bring this pursuit closer, since 2017, Formula Student has a driverless cup. And since 2020, the Hanse Racing division has had the ambition to take part in it. So, first of all, I would like to take you through what the current state of our driverless team is. As the car has only been finished now, we haven't had a car to test and compete the driverless in the driverless cup. However, since we're already 3 years active, we have been heavily developing on a smaller card you can see on the slide. This is me when I joined a year ago, and since then we have been making sure that we test as much as possible of both software and hardware, all the possible sensors and all the quite huge already, software stack to be able to make driverless cars, because it's quite a complicated feat. Further on, because we're all just students, we have been also gathering knowledge from other teams. By talking to them, we're trying to figure out what is actually needed to make a driverless car. And by now, we have quite a solid understanding, and that's what I would like to walk you through in the last couple of slides. So what do we actually need to make a driverless car? I will try to make it as simple as possible, just 4 steps, just to lay out what needs to be done to make this beauty drive without a driver. So, first of all, the car needs to sense the environment. For that, we will add a LiDAR and a camera, which, as you can see on the picture, the track for the Formula Student is laid out of cones of different colors on each side of the road. and those need to be recognized and mapped. The camera will make sure that the cones are recognized with their respective colors, and the LiDAR will make sure that we take as precise measurements as possible to put them on the map later on. So the first step, of course, the environment sensing. Next up, we need the vehicle to sense, to get as much information as possible about the vehicle itself. That includes speed and position on the map. And to do that, we use many sensors, which many of them will be redundant, and we will see how to deal with that in the next step. The next step I called computation, because it's just a lot of computation. Each of these parts could be written a whole PhD thesis about. Very complicated topics, and which we will all need to handle. Starting with sensor fusion, as I said, there will be a lot of redundancy in the sensors. And to get the most accurate position, we need to combine this data, and that is called sensor fusion. Further on, we need to build a map of the perceived environment, coming back to step 1. That is called mapping. Meanwhile, maintaining knowledge about the position of the car itself within the environment. That's called localization. And those two processes will be solved in a process called simultaneous localization and mapping, also called SLAM. When that is done, we already have a map of the environment and the car in it. Then the next step is to plan what to do ahead. That is called path planning. And as you can see on the infographic, the car is figuring out the black path ahead of itself to follow. And the last step is to follow that part. And for that, we're employing very fancy control techniques to achieve the maximum performance and race as fast as possible. And we're using model predictive control, which is an amazing invention. Let me know if you want to know more about that. I'm super excited. Anyway. Last, but certainly not the least, we need to put all this knowledge into action. And how are we going to do this? We need actuators. That is going to be very challenging to change on this car, because we need to be able to steer, brake, and also use put gas. Yeah, make it go fast. My English be bad today. Yes, for that we have asked for help some project groups from Hanse. I see some familiar faces in the audience, so I already thank for contributing to the future. And yes, this is basically the final step in making the car driverless. So I hopefully this sums it up in the broad terms. Now, with that being said, with all this wonderful knowledge we have acquired, with this team and now finally a car, it is a pleasure to announce our goal for the next season, which is to get rid of the driver and convert the 05 into a fully driverless car and compete in the Driverless Cup. Yes. Thank you very much. I think it's very exciting. We have been waiting in the driverless team. I have been waiting for long to have finally a vehicle we could turn into a driverless beast that's gonna drive so fast. So I'm super excited about the future, and I hope that many of you will still stay with us and experience this amazing journey, either as a student, as an engineer to learn, or as a sponsor standing on the side cheering for us and coming to our reveals and listening to our wonderful presentations. That basically wraps it up for the driverless department. And with that being said, I would like to once again, for the whole team, thank all of you that took the time to come here today, because this is a big event for our team, a big deadline for us, big thing that we have been all thinking about and working towards for a long time. And I'm very happy to finally stand here on the stage and not only to announce new plans in the future, but also celebrate this car. You might be having many questions about what is this actually, or about anything what we said. And for that, I would like to invite you to ask questions afterwards. We will be all around. You can recognize the members, of course, with their shirt. And of course, I would like to also invite you to just spend some time here with us during this wonderful afternoon where we get to celebrate this wonderful feat. Thank you very much.